Right. So barometer consists of,
Wait, it's called a liquid barometer, or is this a liquid heading?
it's a liquid barometer. So liquid barometer consists of glass tube, right? It's of a glass tube, right? Okay. And that is filled with liquid, right? And that is inverted into a container.
What do you mean by inverted?
Inverted. You can see here that if this is a glass tube, right? So we place it inverted.
Oh, okay.
So into a container, okay, of the same uh what we call it a same liquid, right? And with the with the vacuum at the top. Now what happens is since the air particles are here, right? So do they exert a force to the liquid? Do they exert a
Yes.
force? Yeah.
Yes.
So what we can say is that the force exerted by the air particles. Okay. So due to which, what happens? The air, the the air pushes pushes the liquid up the tube, right? Up the tube. So what will happen if the particles are applying a force? So they are pushed and then they have the space to rise inside the tube, and then this is how the liquid covers some height. So it depends how much the pressure is exerted by the air, so that it will cover some height, right? It will cover the height inside the tube. Is this clear? So what we know that whatever the height is actually covered, okay, height of the liquid, right? Height of the liquid in the in the column of the glass, okay, of the liquid, the height of the liquid, in the column of the glass tube, I can write in this way: liquid in the glass tube, in the glass tube, right? So indicates what? What it indicates that how much the air pressure or atmospheric pressure is exerted, right? So the height of the liquid in the glass tube indicates uh, the atmospheric pressure. So that this means higher the atmospheric pressure, higher the atmospheric pressure, higher the atmospheric pressure, the higher the liquid rises in the tube. The liquid rises in the tube, right? Okay. So the another unit of pressure um, is ATM, right? Another unit of pressure is ATM. Another unit of pressure is ATM. That is atmospheric pressure. Okay. So 1 ATM, if I want to convert the 1 ATM into Pascal, right? So how will I be able to convert Pascal or Newton upon meter square? Yes, 1 ATM is going to be equal to how much Pascal?
Uh, 1,000.
Okay, so we gonna work in this way. We will take the mercury, right? That is the standard that we have, we have made. Okay, so first of all, we should know the density of the liquid that is, there. So density of the liquid, that is mercury here, it is 13600 kilogram per meter cube. This is the density of mercury, 13600, right? Okay, and the height that is covered, the height that is covered when there's 1 atm. What is 1 atm? 1 atm is actually the atmospheric pressure. 1 atm is the atmospheric pressure when the height is covered by the mercury. When the height is covered by the mercury is 76 centimeter. I'm repeating. 1 atm is the pressure. 1 atm is the atmospheric pressure, which is when the mercury covers how much distance in the liquid column? Covers 76 centimeter, okay, height in the barometer, right? This arrangement is known as barometer. Now, if I say 2 atm, 2 atm will be equal to how much centimeter? For the 2 atm, it is going to be 76 times 2. It's going to be 152 centimeter. So this means that if we want to convert this 1 atm to Pascal, right? So we should have the density of the liquid, that is what? 13600 Newton upon meter. Sorry. It's kilogram per meter cube. And the height that is covered in meters is going to be 0.76 meters, right? Okay. And the strength of gravity is going to be 9.8 meter per second square. Now, can we use this formula? Pressure ATM is going to be rho GH. Yeah. Did I discuss in the last class what rho GH is?
Yes, yes.
Okay, so we did this. We covered this one. So the pressure in ATM is going to be 13600 times Rho is 9.8 times 0.76. So what do we get? Calculate, multiply these numbers and let me know the answer.
101,292.8.
Okay, so that's going to be equal to around 1.01 times 10 to the power 5 Newton upon meter square or Pascal. Okay, 1.01 into 10 to the power 5 Pascal. So now onwards, what you can say is 1 atm equals to how much? How much Pascal? 1.01 into 10 to the power 5 Pascal, right? Okay. Now, what do we know about the atmospheric pressure? That atmospheric pressure is maximum at which level? Is maximum at the sea level. And if you if you go at a altitude or height, okay, at altitude or height, the atmospheric pressure is lesser. Atmospheric pressure reduces. So what does this mean? That if I'm going to, if I'm working with the barometer, I have this at the sea level, right? And the height that is covered at the sea level is, if I have the water here, okay. So let's take the mercury, right? So I have this much height, okay, this much height at the sea level, right? Now, if I take this to the to at a to at a height or at a high altitude, so what will happen? Uh, this height is going to be decreased, right? And the new height is going to be, let's say, h2. Yeah, clear? So this means that if I want to find out the pressure difference, so it's going to be it's going to be like this: rho g delta h. Why delta h? That is a change of height. Okay, so rho g h, and h is going to be h1 minus h2. This is how you will find out the change in temperature. Are you getting this? Hello, is this clear?
Yes.
Right? So that there will be a less height covered by the liquid. Okay, if the atmospheric pressure is lesser. Now we're gonna do one question here. Should I move or should I wait? Hello.
You can move.
Okay, now calculate the depth of the water in a swimming pool where a pressure of 20 kilopascal is exerted. Okay, due to the water. The density of The density of water is 1000 kilogram per meter cube and gravitational field strength on Earth is 9.8, right?
Yes.
Newton upon kilogram. So we have to find out the depth of the water in the swimming pool. What we know is we know the pressure, right? Okay, where the pressure of 20 kilopascal is exerted due to the water. So the pressure due to the fluid is going to be pressure by the fluid is actually 20 kilopascal, and we can write in 20,000 Pascal, right? Yes, and the density is also given to us. So density is 1,000 kilogram per meter cube, right? And the gravitational field, that is G, 9.8 Newton upon meters. Oh, sorry, Newton upon kilogram. Now, what do we have to do? What do we have to find out? Yes, we have to find out the depth of water.
Oh, yes, we have to find out the height.
Yeah,
So we
so
have to rearrange the formula.
yeah, so we can make the subject. So we know that pressure is actually rho g times delta h, or we can make the delta h subject. So delta h is going to be this pressure upon rho times strength of gravity. So the pressure is 20,000 divided by the density is going to be 1,000 times strength of gravity, that is 9.8. So it's going to be how much? 20 by 9.8, right? 20.9.8. How much should be the answer? 20 by 9.8. It's going to be around something 2, approximately 2, I think.
2.04.
2.04 meter is going to be the height that is changed due to this pressure. Okay. Did I talk about the conversion from liter to meter cube? You remember? Liter to meter cube. 1 liter equal to how many meter cube or the centimeter cube? Did I not talk about that?
Sorry, can you repeat?
1 liter. Remember this for your calculation, because some of the times the volume is given in liter, right? If the volume, if volume of liquid is given in liters, so how you need to convert into meter cube, right? Okay. So what you do is 1 liter equals to 0.001 meter cube. Okay, right? And in centimeter cube, it's going to be 1,000 centimeter cube, right? And 1 liter equals to 1 decimeter cube as well. So you have to keep these conversions in your mind. Only one thing is I think one is enough to memorize. 1 liter equals to 0.001. Okay. So we're gonna have one question. Let me find out that one, and then I'm going to do with you. Yes. Yeah, Hamza. So if you can see here that there's a density that is given, which is how much? 1028 kilogram per meter cube, right? And the next question, sorry, the question says that, oh wow, its pressure is also given here. The atmospheric pressure is 101 kilopascal, right? 101 kilopascal means that 10 to the power 3 Pascal, right? Okay. And the diver uses compressed air to breathe under the water. 1700 liters of air from atmosphere is compressed into 12 liter gas cylinder. Okay. So the compressed air quickly cools to its original temperature. Calculate the pressure of the air in the cylinder. So inside the cylinder, how much gas is there?
Sorry, I don't understand your question.
Read the question first.
Don't you just do 1700 divided by 12?
1000, 1000 what?
1700 divided by 12 to find the density.
Density is already given here, right?
Wait, can you go up? Sorry. Oh, okay. So, so why did they say 1,700 liters of air from the atmosphere is compressed into a 12?
It is compressed because this amount of the air that has to be compressed. Okay. So when the diver enters the water, so that compressed air has to be there. So the volume reduces, right? Okay. So the one volume is given here, another volume is given here. Yeah. Yes.
Yes.
Okay. So this says that V1 is going to be sorry, 17, not 12, 1700 liters, and the V2 is going to be, why it is not working? Oh my God. Can you see the screen? Hello, Hamza?
No, I cannot.
Where has it gone? Okay, yeah, it's here. Okay, so V2 is going to be it's going to be 12 liters, right? And the atmospheric pressure that is given to us is going to be let's say P1. Okay, let's say P1, it is 101 kilopascal, that is 10 to the power 3, right? Now when there is a change of the pressure and when there is a change in the volume, so we use a Boyle's law, right? And what Boyle's law is about, it's difficult to work on this platform. Boyle's law is actually it says that when the uh, pressure pressure is inversely proportional to the volume. Pressure is inversely proportional to the volume. Inversely proportional to the volume. If you increase the volume, so the pressures of the gas is going to be decreased. Okay. So if we can have a initial and final states, so P1 V1 equals to P2 V2. That means the initial condition, this is the initial condition, and after the change, there will be a final condition. So this is the mathematical expression of the Boyle's law, P1 V1 equals to P2 V2. So do we have the two temperature, sorry, do we have the two volumes? Do we have one pressure? Yeah.
Yes.
Okay. So what we do is we're gonna make P2 a subject. So P2 is going to be P1 times V1 upon V2. Okay. And then after that, P1 is going to be 101 times 10 to the power 3. And V1 is going to be 17 liters, right? Okay, you can 1700. Okay, 1700 liters divided by V2. What is V2 here? That is 12 liter. Okay. Uh, if you can please tell me what should be the answer by calculating by plugging these values.
Is it 101 times 10 to the power of 3?
Sorry, 100 times what?
Sorry, never mind. I got it.
101 times 10 to the power 3 times 1700 divided by 12.
Uh,
So what?
1.43 times 10 to the power of 1.43 times 10 to the power of 8.
Okay, so if you can write in the kilopascal, is it going to be for what 1.4 something, right? You
One
telling about.
1.43 times 10 to the power of 4.
Okay, so we can write in this way. I think 143,000
08. Zero.
kilopascal. You can check it out. Okay, you can check it out, right? Okay. Is it done? So I can move on.
Yes.
All right. What about this question? State the equation linking pressure difference, depth, density, and rho. So what should be the answer?
Uh, Pressure difference equals the depth times density times gravitational force.
Yes. So pressure is uh pressure equals to pressure difference. So we will write delta P rho G delta H, right? Now, this problem, what does this problem says? That calculate increase in pressure when the diver descends from the surface to a depth of 11 meter. Now, 11 meter, from the 11 meter, it is coming, right? From 11 meters, it is coming. So they're asking increase in pressure because as the diver goes deeper and deeper, so due to the more amount of the water particles above the body, the pressure will be more, right? Yeah,
Yes.
this is what we have developed the concept, right? So what we do is we will just we are going to use this pressure equals to rho gh, right? Okay.
Yes.
So the density of the liquid is, what was the density? It was 1028, right?
Yes.
Okay, 1028 times 9.8 times 11, right? What should be the answer? Let me know.
1.1 times 10 to the power of 5 or
1.1
11
times?
10 to the power of 5, or you could say 110,818.4.
Yeah, so I don't know what numbers are coming after point one. So I'm just putting 1 and 2. So it is going to be 10 to the power 3, right? Or 110 kilopascal, right? So 110 kilopascal, right? Now, what's the next question? They're asking calculate the total pressure on the diver at the depth of 11 meter. So, assume that atmospheric pressure remains at 101 kilopascal. So, we have to work for the total pressure. So this time the pressure due to liquid plus pressure of ATM has to be added, right? Yeah.
Yes.
So what do we have to do is pressure of the liquid was 110, okay? 110 kilopascal plus the pressure due to ATM. It was how much? Atmospheric pressure was 101 over here, 101
Yeah.
kilopascal. So it's going to be uh 101 kilopascal. So the answer would be 1 and 1 kilopascal, right? No, 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 no. It should be 101. Sorry. It should be
Yeah, I
1.
was
So it's going to
so
be
200
2
now.
to 11, right?
Yes, I was confused.
Okay. What about the as the diver breathes out? Beta, where's the cursor? As the diver breathes out, bubbles of gas are released and rise to the surface. So bubbles increase in volume as they rise. So explain this increase in volume because the pressure decreases, right? Yeah.
Yes.
Okay. So the pressure decreases as pressure decreases, the volume increases, and this is how you can, continue to write. Okay.